In this video, we'll be looking at increasing and decreasing functions and slopes. Now, in fact, this is actually two topics, but I would like to look at it in one video because I want to make sure you see the difference between asking about an increasing and decreasing function versus asking about an increasing and decreasing slope. Now, an increasing and decreasing function is very easy to see, actually, once you know what you're being asked. So if you're being asked, in this example, where is this function increasing? So when a question says, where is a function increasing? It's simply saying, where is the graph going up? So from A to B to C to D up to E, the graph is going up, which means our function is increasing from A to E. So we can write that down. Okay, but on the other hand, if we are asked where our function is decreasing, we can see that from E to F it's going down, to G and to H it's going down. So from E to H our function is decreasing. And that's pretty intuitive. It's exactly what we're seeing is exactly what's happening here. So our decreasing function, I hope that's what I said just now. Our decreasing function is from E to H. And again, that's if you're being asked about what's happening to the function, not what's happening to the slope. On the other hand, let's see what happens if you're being asked whether or not the slope is increasing or decreasing. Now, on the other hand, you may be asked about increasing or decreasing slopes. Well, in this case, you're no longer looking at the function and whether or not it's simply going up or going down. You're actually looking at the slope at specific points, which is continuously changing. So in order to see that, I always like to draw a little guy standing on a hill. So I visualize this as a hill. And let's imagine him walking up the hill or climbing up the hill. At A and B, he'd be having a pretty easy time. Well, actually, at A, it's pretty easy. B gets a little harder, and C, it's pretty difficult. Now, as he's on his way up to E, then it starts getting easy again when he's close to the top. And then when he gets to E, he feels like he's made it. He's like, whew, now I can stand on a nice flat surface. And then he keeps going down the hill. And at F, he's pretty much going down. Like he looks like he's skiing down a hill. While at G, it's almost flat again. And then he gets to H, and he's like, oh, okay. Now I don't have to worry about skiing down this very, very steep slope. So now, let's look at what this means. Okay, so as he's going up the hill, his slope, the slope of the curve in general, is positive. So that is a positive slope. Going down the hill, we have a negative slope. And when he is flat, when he's not worried about climbing up or running down, his slope is 0. Now, that's not enough detail. We actually need to know, when we're looking at increasing and decreasing slopes, exactly what is happening in exactly what point. So as we can see, from A to C, it gets harder and harder and harder for this little red man to climb up the hill. So from A to C, our slope is increasing. So we can actually put that there. From A to C, our slope is increasing. However, let's put slope so we know we're specifically talking about slope. However, from C to E, this guy's having an easier and easier time until it flattens out. So from C to E, the slope actually starts to decrease. Even though the function is increasing, the slope is decreasing because the guy, our little red guy here, is having an easier and easier time climbing up our hill. So we have decreasing slope. From A to E, as we know, or from A to D, and almost right before E, we have positive slope. So I'll just put a plus sign there for that. Now, from E to just before H, so right after E to right before H, we have a negative slope. But let's look at the details there. At F, this guy is really going, as we said before. So that is where our slope has the most absolute value. So the absolute value of our slope, the number of the slope here will be biggest. However, it gets closer and closer to zero as it's going down further because the guy's having an easier and easier time. Remember that. We didn't discuss this before, but remember that the guy's flat here, so the slope actually at H is 0. Where else is the slope 0? Let's get those in. If you said E, you're correct. The guy's standing up straight. He's not going up. He's not going down. So the slope is 0. And at I, the slope is 0 as well. So, as we were saying about the guy as he's going from F down to H, his slope was very negative at F, and then it approached 0. It got more and more and approached 0. So the slope is actually increasing here. It's a very, very tough pill to swallow, but the slope is increasing from F to H because here it's very negative. For example, let's put a pretend number on here. At F it could be -2. At G maybe it's -0.5. And as you can see, from F going down to H, it's getting bigger because it's approaching 0. Now, those are just random guesses for the numbers themselves, but as we can tell, the slope is very negative here, and then it approaches 0, so it's increasing. So that's what we mean when we speak about increasing or decreasing slope. So let's finish labeling our graph here. So going from E to F, it's going from 0 to negative. Oh, let's erase that. Hold on. All right, so going from E to F, it's getting negative, so it's decreasing. So it's still decreasing from the side before. From F to H, it's increasing because it's going from negative and approaching 0. So it's increasing. And we can see something similar happening on this side. It continues to increase. Let's use that pointer here. It continues to increase till it gets to around here, and then it decreases back to 0. So that's what we're talking about when we speak about increasing and decreasing slope. All right,